this example together, and this is what I'm hoping. So read the example yourself, try to assemble the important information. Basically, you have the step-by-step procedure, and we want to practice. Everyone has the packet? So it's a pavement slab in Montana, cold climate, I guess. Design strength is 3,000, and a standard deviation is also given. Slab thickness is 12 inches. So this looks like an unreinforced concrete slab, right? There is nothing about reinforcement, so. And then there is some information about air entrainer, that what the specs suggest to use 1% air per 100 pounds cement, and then how much that amounts to the air entraining agent. You should think about it really like a dish liquid. It's really like that. You just add a certain amount to get certain amount of air. And then you have coarse aggregate already 2-inch maximum size. You see, this is given, so don't be confused about that. And then a specific gravity oven dry, that's OD. Absorption and moisture content are given. And dry rodded unit weight is given. So these are important information. For fine aggregates, we have finest modulus, specific gravity, again, oven dry. In the previous example, it was SSD. And then absorption and moisture content. So basically, you need to get started step by step. Assembling information, I leave it up to you to try to highlight the information. However, it's easier that you can access it later. Remember that you are going to need this information later on. Here you see the pavement and slabs as a category. So hopefully you have these tables with you. And these are the things you need to bring to the, like here one of your friends has made like all the tables are in one page. I think it's already with a just a good example. You cannot have a diagram like that. You can have this. Everything else is not that. You cannot have a diagram or something like that. Open, right? So OD is oven dry. So the best use of your time now is in this next half an hour to work on this example with me, and then you are all okay with 40 points in your exam. You know that. Yes? There is no, yeah. This is the only kind of problem, numeric problem you will have. All rest is conceptual. So we are choosing, I'm choosing a larger slump for better workability. And then maximum size aggregate for unreinforced concrete slab. You saw it previously, and this is, it was 12 divided by 3, and you have some constraint in the in the problem. So what would you choose then? Sorry. So have the steps next to you and try to really work it on your own. This would be the best use of your time. I'm here to help. I'm using 3 inches. What is going on? I'm using 3 inches slump. That's the maximum. You can use 2 if you want. It's a design. How much should I use? So what is MSA you chose? Okay. What is the maximum size aggregate you chose? So it has to be less than 12 divided by 3. From here, and also it says it has to be less than 2 inches. And if you put this together, you have to go with 2 inches. And then water. This is 2 inches. Slump, I chose 3. So the amount of water, pounds per cubic yard. This is Montana. And possibly severe. If it is not very obvious to you, for whatever reason, if you don't know where Montana is or whatever, you can just make an assumption, write it down. Don't worry about it. Any other questions? Don't wait for me. You have the steps, you have the table. Just continue. Oh, this is cool. So the tables are separate from equation sheet. You can have your equation sheet as usual, whatever you want to put there. And you can have your tables. If you want to print each one in one page, it's fine. If you want to put all of them in one page, it's fine. It's completely up to you. Put your name on everything you bring to the exam. Okay. So now you have the water. You need to calculate we need to check if you want to reduce the amount of water because of the shape of the aggregates. You have angular, so it doesn't really work. And now you need to find water to cement ratio. I want to see that you do this on your own. So just ask me questions and move on. No. So the equations for, let's say, MSA or the table for water reducer, you can include all of this. Anything which you don't have to memorize, you don't have to memorize. Anything from the code. So the graph for water to cement ratio versus strength, it's either using the graph or using the table. So we talked about the strengths last time. You need to here boost the strengths. Add this. So that's actually what you bring to the table. I skipped through this. This is something else. And if you use interpolation, I saw that a lot of you have this already. That's for strengths. And you also have to consider durability. So what you do is what is given. So what you enter is 3,000 plus 1.34 times 250. Because the standard deviation is given. And this is what you get. I saw a lot of correct answers. Those are like general guidelines if you have no other information. And then if you look at durability, there is no mention of corrosion or sulfate, right? So that would be it. So what do I choose between 0.55 and 0.45? The smaller one. Yeah. And then you can calculate the amount of cement. Is there anyone who is not following? Did I leave anyone behind somewhere? Okay. Then start with the calculation. Okay, you can ask me questions. So this is the amount of cement. And air trainer here was based on the amount of cement. If you see in the problem, it says 0.5 per 1% per 100 pound of cement. So we have 5% air and 588.9 pound cement, and that's why this is kind of, you calculate how much from air and trainer you should add to your mix. This is very practical. This is really what we do when we design concrete. I keep it for a second. It was 0.55 for a strength, and then you also have to consider durability. And then you would get 0.45. And between the two, the conservative design is to go with the lower number. That's important. So you always consider both the strength and durability and choose the most conservative. Any other questions? This is something which is written on the air and training box, like how much per cement, how much per air void sometimes, and that's, you just multiply. And this is the 5% we got from the table, and this is the amount of cement. So this is okay. So now that we have the cement, we need to calculate Ca content. So in the exam, for example, I gave this value. This is sometimes called coarse aggregate fraction, CAF. So if you see that this is given, there is no reason to be confused. It's just given, you can just use it. You don't have to use the table. So don't be confused if something is given to you. That's a good thing. And it's to save time. So we have the finest modulus, we have the maximum aggregate size, finest modulus is here, maximum aggregate size. So again, take a note, if you see CAF, that's what it means, right? And then you make an interpolation, in this case it's an average, and you get 0.75. And then we need to, like before, we need to calculate then the weight. So this is, remember this one was apparent volume. So you need to use the oven, the dry rodded unit weight eventually. So I'm calculating first the volume in terms of feet cube. Like last time, you can combine the two steps, no problem. And to get the weight, you need to use the dry rodded unit weight, just like last time. In the above, I'm just turning yard cube to feet cube, just that. Nothing else. And this is oven dry weight. And then it's easy to go to SSD condition. So you multiply, like I explained last time, by 1 plus moisture content %. This is somewhat easy for me to remember. You can also just use the formula. And also moist condition. And you see that since the material has a lot of moisture, it's actually giving water. This is larger than that, and that's fine. So on the state of aggregate, this is the last one to the right. If you have that picture in mind, remember? The strange looking aggregates, oven dry, air dry, moist, and SSD and moist. It goes like that. So, this is coarse aggregate. Do I need to keep this for a few more seconds? No? Can I answer previous step? I just want to make sure that we go to the end of this. Here. Here? Oh, it's because you found this in a table, your set. 5% air content. Any other questions? This is just like what we did last time. And how do we find sand? We calculate the absolute volume of each component, right? And we subtract it from the whole. This is what we did. I told you. You calculate absolute volume of each component, the rest you keep on the sand. Think about it this way. That's how it works. Now, from weight to go to absolute volume, you need to use a specific gravity. It's fine if you want to also write this down somewhere, 3.15, or these kinds of numbers, if you think you will forget. Water, we know the weight. We just divide by specific gravity or density. Coarse aggregate. And here, because the specific gravity is oven dry, you need to use the oven dry weight. Just be careful. Last time it was SSD in the other example, right? It's simple, just you need to be careful. Air, it's not negligible. The weight is, the volume isn't. And this will be sand. So in 1 cubic feet, in one cubic yard, if you take everything else away, then how much is left? If you calculate these and they are more than 27 something, you say it's wrong. So check your calculation. It shouldn't be. And once we have the absolute volume of sand, what do I do to get the weight? Specific gravity. Here is oven dry, so you can use the oven dry to get the weight. So I get first oven dry, then SSD, then moist condition. And then you have to put this in the table and try to adjust the amount of water. That's all. If you are done with all of that, put everything in the table. I've made the table summary. You will find it in the notes. There is a table summary on page 5 of your handout. Then you can put all the numbers and adjust the water. Is there anyone else who's still writing? Yes. Okay. So the only difference here is that it's not all viscosity. So it's actually the other way around. The moist is giving water, so you need to reduce the mixed water. It can be that one of them is giving, the other one has deficit. So one is plus, one is minus. But it's not difficult. You just need to be careful. So this is because this is 0.2%. I guess this is kind of, if you look at the problem, this is 3.67%, etc. So very quickly, let's wrap this up. So these are the numbers. You put the 265, what you get for the table again is for SSD. And you calculate the total weight of the batch. And then you see now we have extra water. Extra for coarse aggregate and extra for sand. And this you need to subtract now from 265. At the end, the total has to be the same for all of these. It is possible that one is deficit, one is extra. You should not be confused. Okay, and for the dry, you do the same, exactly the same. The answers are on Canvas, so you can check later on. The video will be on YouTube, so there is nothing to be worried about. Okay.